How to select thermal interface materials. Imagine trying to keep your computer cool during a long gaming session or a high-powered work project. The secret often lies in the tiny layer between your processor and the heat sink. That layer is called a thermal interface material. Choosing the right one can make a big difference in how well your system cools. First, think about how well the material conducts heat. You want something with low thermal resistance and high thermal conductivity. But remember, the material's ability to transfer heat depends not only on its properties but also on how well it contacts the surfaces. A very thin bond line with good surface wetting helps reduce contact resistance. Applying enough clamping force compresses the material, making the heat transfer even better. Next, consider if the material is compatible with your components. Some materials can degrade over time or under high temperatures. For example, certain thermal greases might dry out or pump out over time, reducing effectiveness. Mechanical compliance is also key. The material should handle differences in expansion between parts without cracking or separating. Application ease matters too. Thermal greases are simple to spread on flat surfaces, but pads or phase change materials are better for irregular shapes. Some TIMs need curing or special handling, which can add to manufacturing time and costs. The flow behavior of the material, called rheology, affects how well it fills gaps when pressure is applied. Physical properties like electrical insulation might be needed if the component is sensitive to electrical conduction. Structural strength or hardness can influence how much pressure is needed during assembly and how stable the connection remains. Cost is always a factor. High-performance materials tend to be more expensive, so balancing budget with cooling needs is essential. Common types include thermal greases, which are silicone-based with conductive fillers and easy to apply. Thermal pads are solid or gel-like and convenient for mass production, but they usually have higher thermal resistance. Phase change materials are solid at room temperature but become fluid at operating temperatures, filling gaps more effectively. Adhesive tapes and epoxies can also be used, providing both bonding and heat conduction, but they might need curing and can have higher resistance. In the end, selecting a thermal interface material involves weighing thermal performance, mechanical properties, ease of application, reliability, and cost. For a quick prototype, a thermal grease might be best. For long-term, reliable operation, a phase change material or a specially designed pad could be more suitable. Always match the material's properties to your specific cooling system and operational conditions. Remember, the right choice keeps your components cool and working efficiently, saving energy and extending their lifespan.